we were talking about greatest common factors, right? So we kind of left off on this problem, right? About factoring out the greatest common factor. It's always the first thing we want to try to do. And I told you how the greatest common factor should inherit the sign of the leading term, right? Well, the homework doesn't do that. I couldn't find any problems where it does it correctly. And it's not that big a deal, honestly. But here's an example of a problem from the homework that's not going to do it the way we probably should, right? We should rewrite this with the x to the 9th coming first. So this is what we should do. And now, what's the greatest common factor going to be? What's the biggest thing I could undistribute here? To what power? To x to the 5th, right? Does that make sense? That's the I've got two terms, and each of them has at least an x to the 5th. This one's got more, right? But this one's only got an x to the 5th to give. So I would factor this then. I would factor out an x to the 5th, and I'd be left with what? X to the 5th times what is x to the 9th? Remember, when we multiply like base, x to the 4th, isn't it? Because we add exponents when we multiply like bases. So that would be an x to the 4th, because that's going to give me my x to the 9th. And then x to the 5th times what is negative 8x to the 5th? Right? That's what we should get. That should be the answer. That's not what they do. Okay, what they do here is they tell you to factor a negative number or a greatest common factor with a negative coefficient from the polynomial. Okay, so that's what they're doing. They're telling you don't rewrite it with the biggest powers first. Just in the assignment, they're saying just take it the way it is and factor out a greatest common factor based on whatever term comes first, right? So because it's negative, they're saying, okay, we're going to take out a negative 1 x to the 5th. Does that make sense? Okay, so just so you know, it's a little bit backwards from what we really technically should do, okay? All right, so next issue. What do we do if we're dealing with really large numbers? It's not, I mean, we won't very much. But on these last examples we've done, it's been pretty easy. I mean, these are small numbers, right? What's the biggest number that divides into 8, 16, and 4? Well, that's 4, right? We can get that pretty easily. But what if you had really big numbers, like 144, 108, 210, right? Big numbers. It's not so easy to look at that and see what's the greatest common factor, right? So what's another strategy? Well, we could use a factor tree, right? And we're going to be doing that pretty soon anyway. So this is good review. What's a factor tree? Hopefully you guys remember this. So how do I factor 144 using a factor tree? You remember? There you go. Yeah, we just keep breaking it off into branches until we can't break it any further, right? So there's no one right or wrong way to do it. We just need to find two factors of 144, two numbers that multiply to 144. So we could do 12 and 12, for example, right? If we do 12 and 12, we're not done because I can break 12 apart, right? So 12 I would break up into, what are two numbers that multiply to 12? 3 and 4. Okay, so we could do 3 and 4. 3's done because it's prime. 4 I could break up again, of course, into 2 and 2, right? Then I could do the same thing over here with this 12 into a 3 and a 4, and the 4 breaks up into a 2 and a 2, right? And so then what do we get? Well, we get 144 equals, I've got 2's and 3's, right? So let's look at I'm going to go ahead, well, here are the prime factors that we got, right? Well, I got 2 times 2 times 2 times 2. What's an easier way of saying that? Well, okay, but in terms of the prime factor 2 to the 4th, there we go. So we get 2 to the 4th times 3 squared. Everybody agree? Okay, we do the same thing with 108, right? 108, what are two numbers that multiply to 108? Whoops. $12 and what? 12 and 9 does work, actually. Yeah. And we wouldn't have to pick such hard ones. We could just do like 2 and 54 if we wanted to, right? In fact, let's do that. Let's pick an easy one here where we do 2 and 54. 2's done. 54, what are two numbers that multiply to 54? Let's pick single digit ones. Pick easy ones. Say it again. 27 and 2 we could do, sure. 27. Okay. And then 9 would just be 3 and 3, right? So then what do we get here? We get 2 squared times 3 cubed, 210. Now this one ends in a 0, so what's probably a really good one to do? 10, there you go, right? So we could do something like 10 and 21. 10 is 2 and 5, right? Those are prime. 21 is 3 and 7, and those are prime. So on that one, we got kind of weird, different prime factors. So we get 2 times 3 times 5 times 7. Okay, so then what's the greatest common factor? Well, it would just be, it would be the highest shared power of each shared factor. So look at the prime factors of 144, only 2's and 3's. 108, only 2's and 3's. 210, 2's and 3's and 5's and 7's. So the greatest common factor could only be made of 2's and 3's because those are the only shared prime factors. Everybody agree? Okay. So then our GCF, it's going to have 2 to some power times 3 to some power. Well, let's look at the factors of 2 that showed up. Here I've got a 2 to the 4th, 2 squared. Here I've got a 2 to the 1. So how many powers of 2 are common to all 3? How much could I take away? Just 1, right? I can only take away the smallest power of a shared factor because this one only has 1, 2 to give away. The others have more, but we can't take more than it has to give, right? So we get 2 to the 1 times, same thing with 3 to the 1. The other way we could do that is we could go through here when we look at the factor tree and we could say, okay, well, let's see. They each have a 2 to give away. No more 2's. We're done with the 2's. What about 5's? Well, they don't all have 5's. What about the 3? Yeah, they each have a 3. But then they were done. They don't all share another 3. 7's, nope, they don't all share a 7. So look, it's just a 2 and a 3. See what I'm saying? You could decide what works best for you. But this factor tree can help if you have really big factors. That's not going to happen very much. If you have really big coefficients, that's not going to happen very much for us, though. Okay, let's try this one. Factor out the greatest common factor. So we've got each term has a coefficient. It has a number part and a variable part. So we want to know what goes there. What can we factor out? Everybody agree? The biggest number that goes into 4, 20, and 20 is 4, and the biggest common power of x is x squared, right? So what's left behind then? This time, let's use last time we reversed our thinking, and we said things like 4x squared times what is 4x to the fourth. This time, let's use the division method. So what we start with is 4x to the fourth divided by my GCF of 4x squared is what? What's 4x to the fourth over 4x squared? X squared. The 4's cancel. X to the fourth over x squared is x squared, isn't it? Okay. Next term, minus 20x cubed divided by 4x squared would give me what? Negative 5x. Good. Negative 20 over 4 is negative 5. X cubed over x gives me 1x left over. And then finally, plus, there you go, good, plus, what's this doing? Ooh, that's probably not a good sign. I've never had that happen before. Yeah. Well, let's see if it... So far, so good. Oh, yeah, I guess we're good. Oh, we lost a little bit on that page, didn't we? Well, maybe we won't spend so much time on that page. I mean, we had the idea, right? We factored out... We factored out a 4x squared, and we were left with 4x to the fourth divided by 4x squared gave me my x squared. Negative 20x cubed divided by 4x squared gave me my negative 5x. And 20x squared divided by 4x squared gave me a 5, didn't it? Okay, good? All right. How about that one? Yikes. Okay. Everybody agree? Okay, you got the idea, right? So it's really not that much more difficult than what we had before. What is this doing? That was kind of cool, actually. It was pretty cool, but I don't know what I did. What did I do? How did I do that?
Don't do it twice, because you were trying to make the equal sign.
You're kidding me. What if I go back this way? Oh, are you kidding me? Wow, I like that, huh? Okay, so how about that? So we got numbers and variables, right? So the biggest number that goes into 12, 4, and 8 is 4. What about the A's? The biggest common power of A is A to the 1, right? Everybody agree? These two only have an A to the 1 to give. And the biggest common power, shared power of B squared, or of B, would be B squared, right? Good. Okay, now tell me what's left behind. Okay. Everybody agree with that? Okay. How about from this term? 1, right? Everybody agree? Not 0, 1, because remember what we're doing now, to find out what goes in all these places, we're dividing each of these by 4ab squared. And look, something divided by itself is 1, right? When we cancel vertically, we get 1 left behind. So plus 1. And here I'm going to get a minus, right? Minus 2. The a's cancel. Just b cubed. Okay, we good with that? Okay, all right. Okay, this is a tricky one. This will make you think a little bit. What about this one? Okay, now I got a question for you here. Keeping in mind that factors are things that are multiplied together and terms are things that are added or subtracted to each other. So if I look at this expression on a very kind of a global level, I'm just looking from the outside in, how many terms are there? How many things are being added or subtracted? Okay, because you're looking at, we've got this minus sign in here, and I've got a minus sign there, right? And I've got a minus sign there, okay? But look at that minus sign is inside of a quantity, right? So it's part of a factor. Does everybody see that I've got two factors here? Two things that are being multiplied together, right? And I've got just one factor here. True. Yeah. So I mean, we could call that a factor too if we wanted to. But each of these is a separate term. I'm going to call that one term 1, and that one is term 2. The first term consists of two factors. The second term only has a single factor, right? But there's two big things. There is a minus sign there, but because it's inside a factor, we're not going to worry about that one for now. We've got these two big things that are being subtracted from one another, the first term minus the second term. Everybody see that? Okay, so when we're looking to factor this thing, we're going to look at those two terms and see now with term 1 and term 2, is there anything I could undistribute from term 1 and term 2? Are there any factors that are common that I could undistribute? N minus 5. Everybody see that? They share the factor n minus 5. Okay, so I could factor out an n minus 5, and what's left behind if I do that? N minus 5 times what is m times n minus 5? No, let me say it again. N minus 5 times what is m? M. Everybody see that? It's m. Okay. Now, here's going to be my minus sign. I'm going to put that pink bubble around it so we can keep track of that minus sign. There's the minus sign from the middle. N minus 5, or n minus 5 times what is n minus 5? 1. You see that? Everybody see that? Tricky, huh? Okay, so what's the other way we could have done that? Well, we could have just divided to get what these were, right? We could have taken this first term, m times n minus 5, and divided by n minus 5, and look what happens. Those cancel, right? And that's another way to get that m, okay? And over here I had a minus n minus 5 divided by n minus 5. And look what happens here, right? Those cancel. And so I get my, let's not even include the minus sign because we kept the minus sign kind of separating the two. Maybe that's confusing to include that. There we go. Does that make sense? Okay. All right, that's a tricky one. Okay. So that's I'm gonna end this video so I can separate these two, just to kind of try to keep things really organized for you guys.